How you doing? What we're doing now is port mapping. This is going to take a little time. We might have to do it in a couple of videos. I don't know what. We'll just see how this goes. Uh, okay, the first thing you're going to need to know is what your squish band is. Uh, you flatten a piece of solder. Uh, you better get a kit of this. It's layout blue, layout fluid, whatever you want to call it. Fabricators use this. Machinists use it. Uh, you probably have to order it. You're going to need some verniers. You're going to need to measure, okay? Okay, so what you're going to do, I'm going to show you in this cylinder because I got the other one set up. You're going to flatten your solder partially, and you're going to put it right in your spark plug till you can feel that touch your cylinder wall. And then you grab your flywheel and you just kind of rotate that gently. And you'll get that to snap through. Let it snap through 2 or 3 times. If your solder's too thick, tap it just a little more on a hard surface with a hammer. It'll be fine. And get that measurement. Okay, so that piston right here left a mark. Okay, that's right at the edge of that squish band right here. Okay, this is where it is. Okay, that tells me that's where I need to measure. So I'm going to measure right there. This one come in at about 25 thousandths. I'm not using a base gasket. Generally, it's about 18 thousandths more with a base gasket. You'll measure them. They'll measure 19 point whatever to 22. But the average is 18 thousandths compressed. They go 2 thousandths generally. So if you're using a base gasket, torque it down, loosen it, do that a couple times, and then go ahead and do this with your base gasket you're going to use. That's an important measurement. I'll tell you why. After you know what your blowdown is, or not your blowdown, but your squish band is, write that down. You're going to need a notebook, trust me. You need pen, crayon, pencil, whatever you want. Okay? Take your measurement with your verniers from a place you've marked right by your transfers, and just take that measurement, just go right on down with it, and that's your bottom. Whatever that measurement is, subtract what your squish was, because that's where the top dead center is. So, and then write that down. Now that's your mean. That's what you want to go from. Every measurement is going to come off that. Every measurement is going to be taken from the same place. Okay, right where I put that bluing. Sharpie's a better way, but just it's a reference point. That's all it is. All right. Now that you've done that, and you know where the piston rides in the cylinder, where top dead center is, that determines where your port time is going to be. Now, I've already set this up because I've tried this a couple times and it didn't work already. So, see, I put a ring in there, and I put it where the gap is right above the intake. All right? In a previous video, I've already showed you how to set this degree wheel up. I use a socket, put a bolt through it, a nylock nut, and I put a little piece of paper towel in the socket, so when it goes on there, it don't move. Keep checking that to make sure that wheel ain't slipped on you. Do everything you do on this, do 3 times to verify. Okay, I'm at top dead center. I roll my flywheel by reaching in there. I'm going to bottom dead center with this, okay? This is all good. See that? BDC? That's bottom dead center. Okay, I've got my ring in, put my intake facing the side it's going to face, just because. And you push down on that, okay? That is where that's going to mount. If you're using a gasket, put some bolts in, torque it down, take your bolts back out. Okay, that's bottom dead center. This is going to determine where your transfer is open, all right? Now, this one was kind of a really cool one, because now this is a Husqvarna cylinder, and it's for the 372 XPW, so it's a 75cc saw. But if you can get where you see that right there? My transfers are interfering with where the piston is. It's got to hit the edge of that piston. I don't like that too good. But that's okay. We're taking a measurement. So you're going to do the same thing. Be careful not to move your ring cut. Bring that down until that touches. Take that measurement. Write that down. Okay? You're going to need to know this. Then, you push your ring down till it comes very even with the top of the transfers. See where I'm at there? Can you see that good? Let me get a little more light on the subject in the right way. See that? See how I just nicely got that? It's that way on both sides. You just kind of trust me. Take that measurement. It's all important. Okay, I'm popping my ring back out so I don't have what happened earlier. I ended up shoving it all the way up to the darn top. I was funny as heck. Then I had to figure out how to get it out. Yeah, you make a tool. That's what you do. Okay, so we did all that. Now, you're going to put bluing on your piston. This is why you need this stuff. This stuff etches really nice. So you want a nice sharp something or other with a nice point, you know. Use one of these, okay? A straight one's better. This is just laying here. Okay, get your cylinder back on. It should be bolted on, but I'm going to be on and off, so, all right. Okay, now what you're going to do is, we're at bottom dead center. Just trust me, I'm rolling it over until it says top dead center. All right. We've already covered in a previous video how to check your blowdown, where it starts with a flashlight, with a ray of light. You bring it down to when there's not much light, you can see that light come out. Watch that video. You're going to want to know that. Okay. Write that down. This one come in at 104 with no gasket, which is it's reasonable, you know. And then rotate that all the way around that piston. Just keep rolling it right around till it goes down and just closes the ray of light. Write that down. That's how many degrees that's open at once. All right? Don't exceed 160 degrees. That's my personal rule of open time. On the intake or the exhaust, just don't. In fact, don't even push it if you can help it. This one come in at 152 degrees. It was open, so that gives me some latitude to work with there. Okay, now, why you do this bluing, okay? This is what's really cool about this method. You won't find that. Nobody will tell you this crap. I'm 58. If I was 24, I probably wouldn't. But I think at 24, I didn't know it either. So, it's one of them things, you know. But we're going to share it all. Okay, so what you do is you'll reach in here, get it where you just below the rings, get that area, take your scribe, make a mark, okay? Now, see how easy of a mark you get? It'll be a lot straighter than that and you're not hurting anything, if it was against the bottom of that cylinder. Okay, move your degree wheel 10 degrees. Make another scribe. Take your verniers, make that measurement. All right? And the reason you do 10 degrees, you're going to break it down. 10 degrees in a 371 or 372 just happens to come out that it's 150 thousandths. So that tells me that every degree is 15 thousandths. All right? I work in 2 degree increments. I don't try to split hairs. It's not worth it. All right? So now you know that. So you can convert your inches to, or your degrees to thousandths now. You just learned how to do that. Find that on the internet anywhere. Okay, so that's all good. Okay, I'm going to tell you something right now. And I wasn't going to do this. I was not going to get into any advanced stuff. But I'm afraid you need to understand a few things. You're taking off the roof of your freaking exhaust to help change your RPM range. Let's say you want another 500 or 1,000 RPMs off of that. I'm going to go from 104 degrees to probably 98 degrees on this saw, okay? I want it to be a torque monster. I want it to pull hard, but I still want good darn power right up on the very top. It's a combination of what you do in your transfers and what you do, how much you remove here. Now, I'm going to tell you something. From here, from where them transfers close and your exhaust closes to the top of the cylinder is all that's going to build compression. The more that you raise that roof within reason, the less compression you're going to have. And if you raise that roof too far down to 90 degrees, like some people say do, I'm going to tell you right now, you're going to end up with a saw that'll rev like crazy and it wouldn't pull freaking nothing. Okay? I build logging saws. I don't build hot saws. I already said it before. But unfortunately, they're still pretty hot, okay? They really are. I'll build competition saws. But a saw ain't a play toy. I got a personal thing about that. I've been logging a long time. And so I like to have fun with them. I want them to cut. I pull that trigger, that sucker better go. And that's that, the way it is. All right, so anyway, we covered that. I'm pretty happy with that. I think what I'm going to do is explain I'm just going to explain the intake. Okay, you do the same thing on the degree wheel. Just keep following in the direction of rotation, see where it closes. It just right where it meets the bottom of that floor, write your measurement down on the degree wheel. Whatever you get right here, write it down. And keep track of what you're doing. Do this 3 times. Go all the way around until it opens. Write that down. 160 degrees. That's all that I want to see. Trust me for a while. After that, go ahead and do what you want. Or do what you want anyway, because we all do, don't we? We got that right. Okay, on this saw, it's open 150 degrees. I don't want too much air migrating back through the intake on this particular saw because I'm trying to keep my compression up. I'm trying to promote flow forward. So what's going to happen is I'm not going to go 160 degrees. In fact, that 150 degrees of opening that I've got, I'm going to be happy with that, and I'm not doing a whole lot other than some cleanup. We're going to get into that at another time. Okay, so you learned how to port map your intake, your exhaust, and see where your transfers are and convert that to degrees. Because them measurements that you made from the bottom to the top 3 different ways converts right to your degrees. So you know that your exhaust opens first, the transfers open second, and as it's pushing the fuel and air mixture is pushing the exhaust gases out, it goes down, and I explained all that rotation thing. Okay, so you should be pretty good to go there. Don't push your transfer timing too far toward where that your blowdown is, okay? Meaning how high the roof is, because if you get too close to that, I'll tell you what you're going to have. You're going to have something that sounds kind of crazy, but it won't run for crap. Divide it by half, whatever the degrees are. Let's use 10 degrees or 11, 12, whatever. 12 degrees is easier. Let's say it's 12 degrees difference. The exhaust opens 12 degrees before the transfers do. You want to raise that roof, go ahead and do it 6 degrees, okay? That's 90 thousandths. Okay, I'm going to get into the port work next. If there's any questions, you want to email me, right down there in the categories box. Roll that up. I got an email right there. Leave comments over here if you want. I read all of them. I'll respond to you. I hope I've helped you on this. This has kind of been fun. And I'm really looking forward to the next one, and so it's you, and I know it. This is going to be what you're doing with the port work and doing the actual port work. So stay tuned, guys.